Well, hi, good morning, and thank you so much for joining me in my shop here on February 24th, 2024. A cold, cold day outside. Minus 17 to start with. Wow, what a change. Yesterday was plus 4. Today, minus 17. Holy smokes. So, what I have in front of me is a fantastic radio. This is one of the want-to-have radios for any radio collector. Of course, I don't have the cabinet, so you're not going to be too sure until I show you a picture of what this radio really looks like. Just what we got here. So I'm going to do that right away. I'm going to show you a picture. By now, if you've seen a lot of radios, you're wondering what's going on with this one already. But let's take a look at some pictures of what this really looks like. It's an Addison 5. So these are Addison radios. This is on Radio Museum, and you can see the 5 followed by a letter. So it's a 5A, a 5B, a 5C, and a 5D, a 5E, a 5F. And you can look and see the style of these radios, all very similar. These are very, very desirable radios, especially the Bakelite or Catlin plastic version of it. I believe the version that's on my bench, it has a wooden cabinet. It's this one. It's a 5A wooden cabinet. These are valuable radios as these old radios go. One of these in perfect shape, like let's say one that looks like this style here, or maybe this one or this one. Couple $1,000s is what people ask for these radios. So the wooden one, not nearly so much, but still an interesting looking and valuable, desirable radio, this one here. So that's what this radio is supposed to look like. Now let's take another look at the radio itself. So this one's had some interesting work done to it. First of all, where is the speaker? What happened to the speaker? And what's this thing doing up here? This is another speaker. Can you see the top of it has actually been trimmed away a little bit? I don't know if that's for here or whether it was done in a previous radio. And you can still see this coil here. This part, that's the where the voice coil would go in, right in the slot here, if the cone was still in place. So what's happened here is the speaker, for one reason or another, was determined to be shot. I guess would be the word for it. The original speaker shot. So why not replace it? So one of the challenges with these old radios is a lot of them do not have permanent magnet speakers. They have electromagnet speakers, and that's what this coil is for. Coil is to generate the electromagnet so the voice coil can move inside here. But no voice coil, why bother? Well, the coil serves another purpose. It also acts as a choke in the power supply filter for the radio. A very, very effective choke also. So you can't really do without it. You can if you come up with a different way of filtering the power supply, but generally speaking, if you want to maintain the radio as original as possible, and this one's already quite a ways away from that, you would maintain the coil in here. If to maintain the style of the power supply, do what this person did. For some reason they tore away all the cone, and I don't know why they would really want to do that, but they did. It's kind of slapped together here too. Oh, you had to maintain this to hold this part up. It's all part and parcel of the same thing. Actually, there's no bracket but this. This is the entire support. He's got, it looks like an original screw. I think, excuse me, looks like he's put another screw in here to try to steady it up. Wow. Okay. There's nothing else holding this. Wow. I guess when the speaker was whole, the speaker itself, the frame of the speaker, which has been removed in the back here, Looks like it was riveted right onto these spots. That would have steadied this whole thing right up. But now it's just this screw and its cousin here that are holding this thing together. Wow. And then the string is of course traveling up on this piece and then traveling from this piece to this piece, so it's putting a tension in here too. So not the simplest situation here at all. Word is this radio works. So now the string situation here is a little odd too. The spring here is being brought around like this. This is not how this kind of thing is normally done. This is not done. This would not be done this way. In fact, you can look at this spring clip here, and you can tell it's aimed. It's aimed to the exit part here. The string should really be coming straight out here. What's it doing going in here? Some excess string here was not, I don't know. It's going in and out these holes. It's not done. This is not done the way it's intended to be done. So if you don't have the string instructions, good luck figuring out something like this. You need a string guide to get it correct. Now if we tune this radio, you can see this string coming almost straight through here. That's just not how it's done. It's just not done that way. Okay, but interestingly enough, it all works. You can see the pointer traveling across. Now I'm turning it this way. You would expect the pointer to go that way, but it's going the other way. You can also see a fair bit of looseness in the string, but it's getting there. You'll get right to the end. It stops right in what I'm pretty sure is a registration mark, so it's right on the money. This is a 2-band radio. It has a shortwave band, goes from 6 megahertz up to 14, so it's like I was going to say it's a daytime radio, evening radio. It can do both. Okay, we're all the way the other way. Not quite into the registration square there. The capacitor is closed right down. So regardless of the fact that it's not done correctly or the way it was intended, it's working, except it's backwards. It's backwards. Okay. Now it's come with its own antenna on the back. These antennas are not simple things. These are engineered antennas. If you look at this one, you can see there's a smaller coil wrapped around this part here, and then you have the larger coil out here. I could be mistaken about this, but I believe the larger coil is connected to the tuning capacitor, this part of the tuning capacitor. The smaller coil is the pickup coil that's driving the radio, but I could have, these are done in different ways, and I could be wrong about that. There's 2 capacitors back here mounted on this guy. Okay, these radios don't work well without the original antenna, and I'm pretty sure this is the original here. Of course, the person who worked on this did some pretty crafty stuff. I really didn't finish discussing the speaker, so having abandoned the speaker itself, he's installed another one here, a more modern one with a permanent magnet in here. So it doesn't have the field coil, and that's why he's had to maintain the coil here. And then he's mounted it. What did he mount it to? What did he do here? So he's put a large bolt through into this bracket, and managed to bolt the speaker with just one bolt, so it's not very secure, but it's secure enough. It's clever, and he got around everything here. Why did he leave this exposed like that? Oh my gosh. This isn't soldered. What did he do there? This is a piece of wire with varnish on it. That brownish color, brownish is shellac or varnish. It's not conductive. Oh, this is just barely connected here. But I don't know why you even bother with this piece of wire, because this piece can go all the way over here and make the make the connection here. Why have this piece of wire? I'll probably connect this here right off the bat. Okay, let's take a look underneath. You notice that the capacitor, before we do, has two different sizes of plates, and you can see the outside plate on this one here is bent out quite dramatically, and the other outside plate's been bent out. So someone has done that as an alignment effort to adjust the radio's operation to match the dial exactly. Probably done in the factory. Okay, let's look underneath. No transformer in this radio, 5 tubes. So this is a 5 tube. Oh boy. This is a five tube radio. So the tubes are in series, each one dropping some of the 120 volts, and together they're dropping the whole 120 volts. Each tube taking the same current because they're in series. And typically it's the same tubes over and over. You get one of these radios, you got the same set of tubes in it. There's maybe 2 or 3 tube sets that run in these radios. So surprising to me, well, not surprising because I peeked at this yesterday, but surprising to me that all of this work was done up above, and the old capacitors are still in underneath. We have a 40 sitting right here, and we have this guy. Yesterday, when this old radio was being dropped off, the owner and I noticed something very harrowing here, really. The owner has never turned this radio on, never plugged it in and turned it on. It's probably a good thing. I'm going to get my other camera going here so we can get a closer look at what has happened right here. Let's take a look now. The autofocus is going to be running on this camera, so we might have to just give it a moment. Of course, this is the bracket that the screw is coming into to hold the radio down. There's a little piece of asbestos here. There must be asbestos sheet back in the cabinet. Can you see? You cannot see. Well, first of all, this plate is pushed right up against the capacitor. That doesn't bode well for things. Let me see if I can get a flashlight and light onto it. So the screw that holds the chassis in has been put in and screwed down, and it's gone right into this capacitor here. Now, did it go far enough to cause a problem? I don't know how big the screw is. Personally, I wouldn't put screws into capacitors like that. I have the feeling not a good idea. So, crafty guy working on this radio. What other crafty things has he done here? So coming right off the on-off switch, one side of the on-off switch, the wire going down to 2 paralleled resistors, fairly large wattage resistors sitting here, kind of floating. This isn't normal. Components like that, they go between supports, they go between terminals. They aren't normally floating out there like this. And also, now I think this is probably not got a metal bottom. I don't have a metal bottom for it, but if it does have a metal bottom, then you got a short circuit situation set up here. You got electrical tape, which has done the job. Generally, electrical tape doesn't last forever. Oh, baby. Yeah, that's a good thing this guy didn't get plugged in. What's this doing? Just hanging out here. Oh my gosh, it looks like it was stuck on this. This is a job for the close-up camera again. Don't know how well this will come out, but you can see the solder connection down below the capacitor. And when you look at it with the eyes, I'm sorry about my camera's doing the autofocus thing. When I use my eyes to look at it, it's clearly a cold solder joint. It never melted. It's really terrible. So did the fellow who did all this work, he didn't know what to do with a soldering iron? That's hard to believe. Well, good thing I found this. Didn't just rush and plug it in. Now what if I had plugged in this radio with this wire hanging out here? Well, maybe it's touching nothing, or maybe it's in effect touching the other wire somehow, you know, through the components, and there's a real, what you might call a bolted short circuit in here. That would be the worst case. When I start these guys up first time, I run the power through a light bulb, through an incandescent light bulb. These light bulbs here. So if there was a problem like this hidden away in there, and there was a short circuit, rather than rely on the breakers at Sir Adam Beck number 1 in Niagara Falls to open, or my house fuse, my house circuit breaker, I have circuit breakers here, my circuit breaker to open. Instead, all that would happen is these lights would get really bright, and they would restrict the amount of current flowing in this problem. And I would become aware that something's going on right away, and because the lights would be bright, and they shouldn't be. They should be dull or dim. This is called a dim bulb system, if you like, or a dim bulb technique or method. So I could have got away with it, but I'd rather not plug something in with this kind of nonsense. We might as well pull this capacitor out and have a look at it. Oh, you know, I bet you can't get it out without bending this. Oh, I can get it out. Maybe I can't get it out. Wait a minute. The two of the wires are cut on the end here. This is a foolish thing that was done, I think. Okay, so I'm going to cut this so we can pull it out. So a radio with a field coil usually has small filter capacitors on either side of the field coil, forming a pi filter. And the capacitors are typically 8 or 10 microfarads. They're not really big ones. If you don't use the field coil technique, and instead you've used the, instead of a field coil in the power supply, you have a high wattage resistor sitting there. Is that what he's done here? I hope not. I've got to cut this black wire also. Come out of here. It's going to take everything else out with it. Here it comes. So you can see the point where the screw was shoved into it. Oh, went in quite a ways. That can't be good for it. Whether this would lead to a short circuit or not, hard to say. I mean, I guess ultimately it would. If you pushed far enough in there, it would certainly certainly short out. And it would be exciting because you'd be shorting out in a high power part of the radio, and there's potentially quite a charge stored in here. Of course, you're not going to put the screw in while the radio's operating. It looks like a metallic surface down there. I doubt it, but it looks like it. Just watching that. The ohm meter jumps, I'll be freaked out. So what he's done here is he's grabbed this 3-part capacitor, 4045. He's abandoned the two 40 parts, I think. Oh no. He abandoned 140 and the 5, that's the green wire. And he just used the 40 in here, one of the 40s. There's another 40 sitting here. But typically a radio like this would have a couple 10s. Okay. And then there is one changed capacitor, this bright red one you can see. This is the feed from the volume control into the audio circuits of the radio, and he's replaced that one. But I don't think anything else has been replaced in here. Okay, there's a few things to think about. I'm going to go drink a little coffee, and we're going to see if we can get this guy operating in here today. Before we go too far with the radio, we should spend a little bit of time looking at the schematic here, see what kind of information we can pick up. First thing, the way they've arranged these tubes is a little bit confusing. This one is upside down from the usual look. The plate is at the bottom, so you might imagine, well, that's how they've done all the tubes. But look, this one, they put the plate on the side, at the side. Okay, so just something worth noticing right away, so later when I'm looking at these, I'm not, caught up in my paradigm of how they should be turned. Okay, and what are they? So typical 12 SA7, SK7, SQ7, 50L6 output tube, and a 35Z5 rectifier. It's just a very, very common set of tubes in radios like this. We take a look down here in the power supply area. So after the rectifier, we have this pulsing DC that needs to be purified, I guess I could say. And so here you see a filter capacitor here and another one here, and in between them is the field coil or electromagnetic coil of the original speaker. And this is still in the radio. This part is gone. This part, I didn't notice it, but it must be in here. I'm looking at the radio right now. Well, it's got to be, should be in there somewhere. Oh my gosh. Can you believe it? This part appears to be missing. So this is the output transformer, and its job is to take the output of the output tube, which involves a high voltage, and change it to a lower voltage, higher current output, which it uses the transformer to do, so it can drive the speaker. If this isn't there, if there isn't one of these here, this radio cannot operate. So there had this, and quite commonly these are mounted right on the speaker. And so, did I look? I don't remember seeing it. There's nothing mounted on the speaker. The new speaker, or the old one for that matter, there doesn't appear to be an output transformer. Well, you know what? That stops the process right there. We got to figure this out. no output transformer, this radio cannot function. Who would know enough to do what they did to this radio, but then install the speaker with no output transformer? Who would do that? Let's take a look at the radio. I just must be mistaken about it. Maybe I just didn't see it. So I certainly don't see any transformer underneath here. Where are you? Oh, there it is. I do see it. It's back here. Right there. Very good. And you can see the output from this transformer is coming right up to the speaker here. Excellent. Okay. Okay. It takes time to get comfortable with a radio. You put one of these in front of you. It takes a little bit of time to figure out the specifics of the radio and the unusual things that might be that might relate to the particular radio you're working on. Stuff you've never seen before, things of that sort. Like, what is this? This piece. It's this long. It very much looks like a switch, but this is the switch between broadcast and short wave. What is this guy? Oh, you know what? Okay, so if we look up here, we see the tops of trimmer capacitors poking through holes in the chassis. And those capacitors are a single block here. There are 3 different capacitors, but they've manufactured them as a single block. I don't know if I've seen that before. Okay, and these of course are for tuning up the radio once everything's operating. Fine-tuning, you could say fine-tuning. Compensating for variations in the manufacturing process too. The pointer is driven from below. Yeah, most pointers are driven from above. They slide along the top. This one's below. It's just a little different. Okay, let's take a look at this capacitor for a second here. Is the capacitor frame isolated from the chassis? So it looks like grommets down under here. Very hard to see. Now these things are often kind of rubber mounted. They're mounted in a little bit of flexation there. Sometimes that is intended to actually isolate it. Oh, I don't think we can see any of that. Okay, so there's 3 screws here. 1, 2, and 3, and I can see the large rubber grommets around them. I see wires soldered to a terminal on this screw. So this screw is connecting to the frame of the capacitor. Okay, with this wire, it's coming right up to the antenna, and a few other things are connected there too. And is it grounded there? There's a I don't think so. No, I don't think so. Let's look up on top here again. So I'm looking for grounding braid or something coming off the frame, but there isn't any. So I have the feeling this is actually not at the same potential as the chassis. And I've gotten quite a good shock once from this situation by touching both the chassis and the frame at the same time. So the plug here is non-polarized, so you're not controlled which way you plug it in. Plug it in this way or that. That means the hot wire could be this way or that. Looking in the radio, okay, we know one of the wires is just free here, and the other one is coming to the switch. So where this free one was going, I'm assuming it's that terminal down there, and is that terminal tied to the chassis? Probably not. Let's just check that. before I power this up, I just like to know. I like to know what I'm doing. So we're looking from chassis to this terminal here, which is the same as this terminal here. So you see there's nothing on the meter. I see a capacitor here that's soldered to the chassis. Now, how many other things are soldered to the chassis in here? For instance, here's a terminal strip. This is the chassis grounded terminal, nothing hooked up to it. So it looks like the bottom of this coil is soldered onto the chassis. But there's 4 leads on the top, so it's probably just a support and nothing more. So here's another terminal strip here. This is the chassis grounded terminal, nothing hooked up to it. So along with there being one capacitor, there's often a resistor. Here's these 2 resistors that are caught my fancy there. Okay, this is one of the filter leads here. I see nothing else anywhere that is tied to ground except this spot with this capacitor tied to the chassis. I don't want to say ground. Let's just look on top here. I think that's it. Okay, let's take a look at the schematic now. We'll try to find this capacitor and its connection to the chassis and see what the schematic tells us about this. It's good to get this stuff straight right off the bat when you're working on these, especially these 5-tube no power transformer radios. So we're looking at the power supply here. Let's follow in on the plug. So we'll just pick one. We'll pick the side that's going to the switch. There's a capacitor right across the line here somewhere. That's not the one we're looking for, but this is an important capacitor. There's a bit of a fire risk with this one. And here we have all the tubes in series right across the line. And here we see a ground symbol. And you notice it doesn't go anywhere inside the tube. I think this is grounding the shell. You'll probably find that true on. So the shell of each tube, these are metal tubes, is connected to the chassis. And I didn't spot any of these ground connections. Also the can of the IF is grounded to the chassis. We go way out here. So this is probably related to the antenna. So we see it's a little weird looking here. I think this is the loop antenna where they've got L. Did they identify it here? L. Anybody say what L is? L for loop. This is probably the loop antenna right here. I'll take that back. This is the loop. This is probably the pickup loop. So remember I showed you the antenna. There were 2 sections. One was obviously a large amount, looks like a racetrack of wire. And then inside was a circle, a small number of turns. And that would be this piece here. And this is the piece that's actually driving into the radio. This piece here, if you follow, if you had a long wire antenna hooked up through a capacitor for safety purposes, through an antenna transformer, transform the energy onwards into the radio. You'd have this switch thrown here to switch between this large pickup coil and this much smaller and much more closely coupled arrangement. A little coil. I don't think I pointed it out on the radio. It's up on top of the radio. And the high frequencies, they don't really see this. The shortwave frequencies don't really see this. This is more for the broadcast band. think I've got this wrong. So this dotted line here is showing all the things that are... Oh, this is the switch. This is showing the switch. Here we are. Here's the tuning capacitor with the two sections. And it's showing them ganged together. One of these capacitors is across whatever is hooked up to the front of the radio, depending upon this switch. So this capacitor could be across this coil here. So this might be the larger coil. I'm not even sure now which is which. The larger coil on the antenna, and the smaller coil might be this one. This is a fixed capacitor here, not tunable. It's probably a trimmer. You probably can tune it, although we've marked them all here, so it doesn't look like it. It looks like this is a fixed capacitor, trimmer here for shortwave, I would think. And then there's a big one here. There's another one here. This is probably a trimmer for the broadcast band. And these are the two that you're turning when you turn the knob. One controlling the tuning of the front end of the radio, the other one controlling the local oscillator frequency. And we got coils here, probably switching coils for the local oscillators, probably what's going on here. Wave change switch shown in broadcast position. Okay. So this ground here is really only connected to the outside antenna and these few parts here. What is this? This is coming over to here. And in some cases you can put a ground on here. Well, when you switch to short wave, you apply a ground here, then the short wave antenna energy is completely focused on this coil, and it's transformed over to this side and on its way into the radio. So that's what's happening here. So you're moving the ground basically from here to here, where you're cutting this out of action when you go from broadcast to shortwave. This guy gets left behind, gets grounded out. Okay, that's what's going on with the grounding here. It's all just related to the antenna coming in. It doesn't have any impact on the rest of the radio. Now this is the capacitor I was pointing to, C7, 0.025. Looks bigger than that, but 0.025. So the purpose of this capacitor, and the reason I'm dwelling on it, is if you didn't have this capacitor, then you'd have this radio just as it is now, and it would operate, and it would work fine, work the same as it does now, except it would have this big piece of metal all around it. The chassis had this big piece of metal all around it. And that metal can cause a couple of problems. One of them is it can convey signals. So a powerful signal maybe existing at the output of the IF can find its way back to the sensitive front end here and come through again, and of course that's an oscillation. Also, the big metal can act as an antenna, pick up signals from whatever, noise and whatever, and present it right to the radio in the most intimate way you can imagine. So to stop these effects, you can put in a capacitor here. You could do this without a capacitor. If you just took a piece of wire and went from here, this is the B minus line here, and connected it directly to the metal chassis, then those interfering kind of things would stop. But now you've got another problem. Now the chassis is hooked up directly with a piece of wire to here, and guess what? If you trace this long enough, I'm not going to do it, you can probably find a way that this connects right back to the power line, right back to one of the prongs on the power line. Probably if you chase up here and here, and I don't know, sooner or later And maybe if you switch the plug this way or that way, it'd be very, very dangerous. You'd have 120 volts sitting on a chassis. So to make it safer, they put a capacitor in here. So the capacitor still allows the high frequencies to pass through while providing a good enough reactance or impedance to a 60 cycle AC that if you're hanging on to the chassis, any power that gets to you through this is limited. So you might feel a tingle, and you'd certainly, if you short this stuff out, you see these funny little sparks. You see, very easy to see sparks, but nothing seems to happen, like nothing bad seems to be happening. That's because it's the charge coming in out of this capacitor. You've probably experienced this, and you've probably, maybe if you've worked on these radios, you've probably experienced what I would call a brush shock, where you brush up against something and you get a bit of a shock, or a tingle shock. I think sometimes that's the term that's used for it. So this is a safety deal. You need to hook the chassis back. This is the safest way to do it. Now, a lot of these have a resistor, like maybe 150,000 ohm resistor in parallel. This one doesn't. Now this capacitor is doing something similar. This connection, I assume this is to the chassis. I mean, it's the same style as this. The size is a little different though, but I think that's just bad drafting. So grab this wire, you're grabbing the chassis, same problem. You could get a shock, you could be out laying your antenna wire out in the backyard, shuffling in your wet lawn with your worn out running shoes that have become wet, and grab this antenna, and what you're really grabbing is the chassis, and the plug is in such a way the chassis is live, and you're not. That would be the end of it. So I think that's the purpose of this capacitor. Now, it could be wrong. This could be compensating for inductance or something, or somehow improving the reception, but I think it's a safety thing here. I could be wrong about anything I'm saying, by the way. I'm not suggesting I know everything about everything and don't get things wrong. The proof is I do get things wrong. So anyway, I think we've stared at this enough. I'm not sure I'm going to extract too much more out of it. What's this? What's this arrow to nowhere? Usually that's into the power supply somewhere. What are they pointing at here? Oh, it's the volume control. Oh, for crying out loud. Okay. And they're just showing it gang to the on-off switch. Yeah, I'll be okay. I have to go drink some more coffee. That's what really has to happen here. Say, how are they doing the biasing of this tube? So if we find the cathode in here, that's a 8. Ooh, that's tricky to look at. Cathode. I think that's the cathode. Oh, it's really, well, what's going on in there? So R8, how big is R8? R8, is it small? No. 100,000 ohms. What's this R6 doing? R6, it's also big. Well, okay, I don't see a cathode. I'm looking R7, maybe R7. No, it's big also. Is it looking just R9? Where's R9? Where are you, R9? R9 is here in the power supply. So what I'm doing is I'm looking for a cathode resistor, and these are all capacitors here. No, there's nothing here. So how are they biasing this thing? If we follow the grid, very hard to do. Oh my gosh. I think this is the grid here. Yeah, to the plate. So it looks like they're relying on something called self-biasing to achieve the biasing of this tube, where basically the tube will generate a negative voltage on its grid if you just set up a capacitor and resistor the right way. And that negative voltage generally is just enough to do the trick. That must be what they're doing here. If we look at these other tubes, R4 is probably a big one. Yeah, 10 megohms, yeah. Or over here, again, following the cathode. Wow, it's really hard to follow. Oh, cathode here. No, so I don't see any. Well, these tubes will be biased by a voltage developed over here in this tube. That's my voltmeter signing off. Okay, so one more thing. Another thing we should look at, the light bulb. So the light bulb is the problem in these radios that do not have a power transformer is it's not easy to find 6 volts to run a light, or any particular voltage to run a light. So what the tube manufacturers came up with was they realized that they could take the heater in this tube, the rectifier tube, put a tap on it, and if they tapped it in the right spot, they could produce 6 or 7 volts, something like that. And so that's what's going on here. So there's a tap, you can see it right there on the heater, and then they power the light bulb from it. It's a 35 volt tube with a tap at about 6 volts on the heater, 6 or 7 volts, somewhere in that range. That's how they're doing it. And they aren't really revealing where's the other pilot wire going. They just show it going there. That's kind of weird. Okay, I don't know what to make of that. That's good. That's good enough for now, I think. Well, I thought I'd check the size of the filter capacitors here, what the radio is calling for. So I think that's 4 and 5 maybe. Can't really read those numbers, but these will be the big capacitors. So if we come over here, no, these are tiny. Oh, CF, A, and B. Okay, well maybe that's an A and a B. There's the CF. Okay, can filter. That's what they're calling it. Can filter condenser. Is there a can? I'm going to look at this radio just for a sec. I'm looking at it, and I don't see any can. Usually there's a can, on top of the radio. I don't see one. Oh, here's a parts thing. Where's the can? Show me the can. What is that? What is that? That is well, that's the output. That's where the output transformer is in this radio. Is that added in? You know what? That output transformer is added in. That's not original. Okay. And what was there is this was the capacitor. They took the capacitor out and installed 2 of them underneath to make up these 2 capacitors. They're 2 very different looking capacitors he put in. And I've cut one of them out, but not the other. Okay, I cut the one out because I had a screw that had been poked into it, and that's the reason I did that. So we're going to replace that one, and the size here is 60/30. So which one's 60? So if it's A and B, 60/30, A put 60, it put 60 on the front. So the 60 is right on the tube. If you put a big enough capacitor here, you'll have trouble because the charging current charging up the tube is substantial. There's nothing to slow it down. So you put a huge demand, or even cause a short circuit to develop inside this tube. So wouldn't this be the smaller one then? Well, that's a mighty good question, but there's already one in here. Let's see, the one that's in here is a 40, 150 volt 40. And that's actually not big enough. It's a 60-30. Well, maybe it's this one. Well, I'm going to put a 50 in. I'll put a 50 in place of the one I just took out. And we'll operate the radio and see, if it works fine, good. If it doesn't, well, not good. Okay, stick it in there. Okay, so I've reconnected the incoming power line. Rather than going down to the connection back there, I just put it on right here. Same thing. And the new capacitor is that little guy down there. Now the thing about this power supply is in most radios, or a lot of radios, you have a couple of capacitors in the power supply filter, and the negative terminals are tied together essentially. In this radio, it's the other way around. The positive terminals are tied together, and the negative ones go separately into the radio. So it's easy to make a mistake at that point by assuming something, and I don't think I've made that mistake. Okay, I think we're ready to start this guy up and see what happens. Yeah, I think so. I can put it like this. And I'm going to go and just take a little break, drink some coffee, and this guy's going to have a go, probably on the broadcast band, all by his lonesome, just with his own antenna there. We'll see what happens. Yeah, break time. Okay, I think we're ready for our first attempt at starting this radio. Now, I mentioned these light bulbs over here, these two up here. I'm going to take one. I'm going to loosen one off. And my tripod is taking. What happened to my tripod there? That's weird. I don't know what happened. Okay, so now we're just down to one light. So all the power that reaches the radio, reaches here, goes through that light bulb. This thing draws a lot of power, light bulb gets bright. This thing doesn't draw any power, light bulb stays dark. On here I've got a device here. These are real handy, by the way. These things are not very expensive. Just this is a kilowatt. I'm not trying to promote it or anything like that. There's lots of these around. And I have it plugged into an extension cord. The extension cord runs basically to this box here. This box controls the voltage that's being conveyed to this box. But I don't usually use this. I usually leave this thing kind of where it is. Occasionally I make use of it. I depend on the dim bulb lights, which I like a lot better actually. Okay, practice session here. That's the on and volume, and that's the band, probably on broadcast this way. And the tuning is back asswards. I'll put it on the pointer. Oh, it is backwards. Okay, so I've got the pointer coming down to the low end of the band. So I'm down, 55, 60. So this would be, 680. CFTR news would be right there. The capacitor should be almost closed, but instead it's almost fully open. It's at the wrong end. So even though everything is moving, it's all wrong. This is totally wrong. Everything is wrong. This is turning the right way. The pointer's going the wrong way. So there's no way you can read this dial. And it'll be the same thing on shortwave. It'll be totally back asswards, I think. Okay, so if you want to tune in, like the local stations during the day are up at the low end of the band, which is up here, which is the closed capacitor. We will try to tune stuff in up here. Okay, glad I noticed that. First of all, no power being supplied here. Turn the switch on. No, I'm sorry, did that wrong. Make sure the switch is off. Apply power and see that nothing happens. So we're kind of testing the switch. With no load here, all the voltage coming from Niagara Falls will show up. 115 volts. Actually, it's coming from nuclear power stations. not too far from here. Okay, so now we cut the power off. My little switch panel over here. So if I throw the switch down, power is being sent here through the light bulb. If I throw the switch up, power is being sent here straight from Niagara Falls. Straight. I got my own feed right to Niagara Falls. So we're going to cut the power, turn it on. Boy, I really dragged this out. Now when I hit the switch, I'm going to watch this light bulb. It should come on bright and then dim down. And what's happening is the heaters in the tubes are heating up. When they're cold, they conduct a lot of current, but when they heat up, the resistance goes up, the current goes down. So you should see the light come on bright and go down, and then sit for a moment, and then start coming up again. Now the thing is, it may be doing that, but it's so dark we can't even see it. It's possible. As it's coming up again, that's because the radio is drawing more power because all the tubes are coming on and starting to do their job. And that involves more power, more power. To some degree, this light bulb up here will do the same thing. The same basic pattern of coming on bright, going down, and then coming back up. But it's for slightly different reasons that this one's doing it. I don't see any reason not to continue. So, switch is on. All I got to do is throw the switch down. Watch that light bulb. On bright, going down, down, down. Down, down, down. Way down. Now it should start coming up again. A little hard to see there, isn't it? So it's just gone right down to nothingness, which is okay. Total voltage being fed to the radio now is 100 volts. That's generally enough for a radio like this to work. It doesn't need all 115. If one tube's lit, they're all lit because they're in series, and I can certainly see a lit tube, and the light indicated everything was going fine also. So still with 100 volts, we'll turn the volume up. Wow, it's really pretty darn quiet. I don't hear a thing. Okay, we'll turn the volume up. We'll try the band switch to see if there's any clicky noises. There's not a sound coming out. So we have a radio here that somebody has done something to it. We've noted a few of the things they've done. Did they ever make this radio work? Did they ever get all the way through it? How about I hook up the speaker? That's an even better idea. I disconnected the speaker earlier and never reconnected it. Hey, that explains it. Yeah, so we're going to bring this wire over here. Yeah, let's make it pop. That's why it didn't work, just because of this. Where this alone is enough to keep it from, obviously you don't have a speaker connected. Let me just nip this off here. Unnecessary piece of wire. Oh, I turned off my soldering iron too. Yeah, you can't imagine somebody did all this work and then never got the radio to work and just gave up. No. Whoever did this got this radio working, I'm sure. And I'm going to get it working too. That's the goal today. Virus and threat protection. No threats found. Once the radio is working and I begin doing the restoration tasks that need to be done, then I'll explain step by step how the radio actually operates. Right now I'm interested in making it work. because that is so important at the start of things. You don't want to be doing a bunch of part replacements and changes to the radio when it's not working, because for all I know I'm making mistakes, and with the radio not working you can't check. Once the radio is working, you can change a part or two and then test the radio again. Okay, this time we actually have a speaker connected. Okay, so we're going to put the switch on. Okay, you know what to look for with the lights. And we might hear everything from a loud hum to who knows what as soon as I hit the switch. We don't know. Okay, no sound yet. Tube's warming up. You should have something by now. We're at 100 volts. Oh, there it is. So turn it up very high. That buzz we're getting sounds like a problem buzz to me. Behind it is some static, which I think is receptive static. So I'm going to touch the antenna here. So it is receiving really weak. Turn it way up. Anybody home? Tune in, tune in, tune in. Very weak. Wrong way. There we are. That's full volume, not full voltage. But we're going to give it the full voltage here. Everybody jump back. Okay, so that interference may not be the radio. Touch more volume when turned up full. That crackling could be the radio. Let's give it the bump test. Very good on the bump test. Nothing seems to be loose. Very good. Okay, now we're in a position to start working on this radio and just try to make it better and better and better until it's working pretty normally. Fantastic. So great. This is a very successful day for me here. So thanks a lot for watching, and tomorrow we'll start the actual step-by-step restoration process on it. See you later. Have a great day.